We're living through this absolutely incredible moment of AI innovation. I mean, the models are getting smarter, faster, more capable every single day. But here's the thing, building world changing technology is only half the battle. The real challenge? Getting people to actually use it. It's a problem that has some really deep historical roots, and to understand where we're going, we've got to look back first.
We've all heard this a million times, right? It's a fantastic line from a movie. But as a strategy for rolling out technology that's supposed to change the world, is it really that simple?
Not even close. In fact, history is absolutely littered with brilliant inventions that just fizzled out. It turns out that having the best tech doesn't guarantee you win the race. And that's a lesson we actually learned over a century ago. And believe it or not, that lesson comes from the automobile. Yeah, the car. To really get a handle on the challenge AI faces today, we need to go back to the early days of the car industry. The parallels are honestly kind of wild. Okay, so this slide tells a fascinating story of two totally different philosophies. On one side, you had Europe. They were the masters of engineering, building these incredible machines, basically the Ferraris of their day. They were beautiful, powerful, and ultimately just toys for the rich. But on the other side, the US wasn't trying to build the best car. It was trying to build a whole new way of life. Henry Ford's assembly line, that was the supply push. But the real genius was the demand pull, building a massive network of roads that made cars a necessity, not a luxury. The US didn't win by out-engineering Europe. It won by out-adopting them.
So that brings us right back to today. Right now, the US is building the most advanced AI models in the world. That's our version of European engineering ingenuity. But are we creating the conditions for mass adoption, or are we just building an amazing niche product for a select few?
And this leads us right to the heart of the problem. This build-first strategy has created what experts are calling the AI adoption gap. It's a critical disconnect, and we really need to wrap our heads around it. So this is it, the core of the issue. We are producing an incredible supply of AI technology, building these powerful engines of innovation. But the demand, the widespread use by all the businesses that actually make up our economy, it just isn't keeping up. We've totally mastered the art of invention, but we're falling behind on the science of implementation. And the data, well, it paints a really stark picture. Just look at this chart. What's truly alarming isn't just that massive gap between large and small companies. It's that even among the big firms, the ones with all the resources, adoption is not only low, but it's actually declining. That kind of suggests that the easy stuff, the low-hanging fruit, has been picked, and the harder, more integrated work just isn't getting done. For a technology that's meant to revolutionize everything, these are definitely not the numbers you want to see. So you might be asking, well, why isn't the market just fixing this? It's a fair question, and there are a couple of big reasons. First, the AI-related economic growth we're seeing, it's mostly from building the infrastructure, like data centers, not from businesses actually using the tech to get more productive. And second, the simple plug-and-play software model just doesn't cut it here. I mean, weaving AI into a hospital's diagnostic system or a factory's supply chain requires deep, customized work. You can't just solve that with a monthly subscription.
Now, this might sound like it's just an economic problem, but trust me, the stakes are much, much higher. This adoption gap is quickly becoming a critical matter of national security.
And this slide right here perfectly illustrates why. While the US is sticking to its build-first strategy, focusing all its energy on creating the next groundbreaking model, China's running a completely different playbook. They have a national mandate that's all about widespread implementation. They're using the full power of the state to create demand and make sure every major industry is putting AI to work. Just how serious are they? I mean, look at this number. China has set a national target to have 90% of its major industries using AI by 2030. That is not some hopeful projection. That is a state-driven, top-down goal. They are literally forcing the adoption that the US is just hoping the market will create on its own someday. And this all leads to a really critical realization. We might be asking the completely wrong question. All this debate over whose AI model has a few more parameters could be a total distraction. The real race isn't about building the perfect AI titan in a lab. It's about deploying a functional army of them out in the real world. Victory might not go to the most perfect innovator, but to the fastest implementer. So if a top-down government mandate isn't really the American way, then what's the solution? Well, the answer might be hiding in plain sight: An untapped army of talent that's ready and waiting to be deployed.
Okay, think about this. At the exact same time, we have this massive national need for people who can help businesses integrate new tech. We have a whole generation of young, digitally native workers facing high rates of unemployment and underemployment. This is a perfect, almost poetic alignment of a national problem with a national resource. There's a huge opportunity here to connect this incredible talent pool with the businesses that desperately need their skills. So, how do we actually build that bridge? Well, there's a fascinating proposal on the table called AI Adoption Accelerators, and it completely reimagines the role that our colleges and universities can play. It's a plan to turn them into engines of practical, widespread adoption. The plan itself is a pretty straightforward four-step process. Step 1, universities don't just teach theory. They actually partner with local businesses to find out what real-world problems need solving. Step 2, they build practical courses to train students on those specific challenges. Step 3, those students get deployed directly into those businesses through projects and internships. And finally, Step 4, you create incentives for those companies to hire that now proven talent full-time.
And let's be clear, this isn't about chasing the next big AI breakthrough. The goal here is to focus on the practical, hands-on, yeoman's work of making AI actually function inside a regional manufacturing plant, or a local logistics company, or a community hospital. It's all about solving today's problems for everyday businesses. But how do you get universities, which are often focused on super high-level research, to buy into this practical mission? Now that's the really clever part. The proposal suggests using a powerful lever the federal government already has, research funding. By offering universities that run successful accelerator programs higher reimbursement rates for their research overhead costs, you perfectly align their financial incentives with the national goal of AI adoption. It's brilliant. And so we are left with this huge, fundamental question. In this global race to implement AI, what's going to be more powerful? A top-down, state-driven mandate, or a bottom-up, decentralized army of innovators? The answer won't just determine a winner and a loser. It will literally shape the economic and geopolitical landscape for the next century.